Hi folks, I'm Dave.
And I'm Ben.
And we are here again. I'm going to do rhyming introductions for the rest of the videos from here on. No, I won't put you through that. A bit too cruel. Right, so we're here again and we are looking at our next really important fundamental coding concept. Hopefully you've already seen our first video, which covers the concept of loops and what to do with them and how they work, where we go over the classic program Hello World, but with sort of a bit of a modern sort of fused twist. And in this video, we're looking at variables. They both begin with V. I think that you can forgive me for that one. Now, they are really, really important to get our heads around when we're learning to code. Variables are in every significant program ever made. They are incredibly useful, and when you realize how they work and how to use them, you will level up in your sort of programming understanding. So what is a variable then? What is it? Well, it's a bit of a tricky one to answer precisely, and it's a bit like everything with computer programming. The real answer, the real correct answer, is just needlessly complicated. Am I right? Yeah, I mean, if I was to really explain what a variable is, we're going to have to go into some stuff that you just don't need to know to actually get started and use them practically.
Yeah.
So we like to, in our workshops, use this example of a box. A variable is a label that you put on a box. And in that box, you can store things. You can store numbers, you can store anything, actually. Text, numbers, calculations.
True or false,
different variables. You can store characters in there, shapes, images, anything that you might actually use in your program, you can store in variables. And they are essential if you want something to change during your program. I mean, hence the name variable, something varies. Exactly. So let's just get into a program, and we're going to write a very simple counter, which just will show you mechanically sort of how variables work. And then hopefully, once we've got that done, we can show something a little bit more silly, which we may or may not have prepared earlier. Yeah, so no need for a big description there. Can I just get you to increase the font size, Ben, on there for us so we can get the viewers to see it nice and clearly on the back screen? Lovely. Right, okay. Now, when you create a variable, you have to give it a name. As I said, it's a label that you are putting on a place to store something. Now, you can name your variables anything that you want, with a few exceptions. So, Ben.
Ooh. Can I call a variable this, Dave?
You cannot, although I commend you for your determination. The reason that you cannot, Ben, is that is already taken. Okay, when you wrote that word, you noticed it turned blue. As we discussed in the previous video, words that turn blue are functions. They are already things that exist in Fuse. It already knows what to do when you write the word print. So you can't actually use this name. If you were going to say print equals a number, for example, so this would be how it normally looks when we create a variable. But when Fuse reads print, it's expecting a bracket and some information, maybe some commas in the brackets. So this is going to confuse Fuse. And actually, it does allow you to do it. It does actually allow you to do it. And we did this so that, it's kind of open and you can do a bunch of different things with Fuse, but it's not advisable. It's not advisable. In fact, really, the person who's going to be most confused by this is the reader, the person reading the code, because they're going to see it. It's the word print. They know this to be a function. Why are we calling it something else? So generally, we avoid names that are already in use.
Yeah, and also other programming languages that you might move on to or move to the side to, not necessarily above. Fuse is very powerful.
Nicely done.
Other programming languages don't allow you to do things like this at all. Yeah, very strict.
They're very strict.
Yeah, but in Fuse, if you learn to not do this, then
it's a good habit to start. Isn't it? It's one of those things like best practice, and it's just as we mentioned in the previous video. You can have your code spaced out however you want. You can have it all on one line. You can have it across loads of different lines. You can have it in capital letters, lowercase letters. It does not care how you write your code. But other programming languages really do. So it's a good place to develop good habits in a place where you're not going to get punished for doing the wrong thing. But generally speaking, when we name a variable, we want it to be something vaguely connected to what we're going to use it for. Because, A name is just a name. It doesn't really mean anything to the computer. I could call a variable socks, and I could put the number 2 in there. But then I might use my variable called socks to describe something completely different, like gloves. The first thing that could come to my mind, what's not socks? Gloves, I don't know. Now, it doesn't matter. Fuse doesn't mind if you have a variable name that doesn't really make any sense. But you will, trust me, if you write a program using tons of different really weird and wacky variable names, and then you come back to it 3 months down the line, and you're looking at this mess, you're going to say to yourself, why did I not use sensible variable names? Now, also bear in mind that we have to type a lot in programming, so we generally sort of stick to meaningful but short variable names. Now, for this example, we are just going to use a single letter. And we use a bunch of different letters sort of regularly and conventionally for variables. You might see A or I equals this, or N equals something, all over the place in the Fuse demo programs. And those letters tend to be short for something. A is usually short for angle, N is usually short for number, I is usually short for index. But we'll go into greater detail about those usages a bit later on in the videos. For now, we'll just stick to a nice and easy N for a number. We are simply storing a number in this variable called N. Now, when Ben runs this program, nothing happens on the screen, because as you know, we've got no print, we've got no update, we've got nothing happening to the screen. All this does is it takes number 2, it puts it in the box, and it says this is called N. So Ben, how could we access this? How could we, for example, print the value of it?
We just kind of gave it away there. We could print and Dave.
This is what I was getting at here, you see.
If I want to print N,
yes.
Surely I want to do that.
Surely you would do that. Now that, Ben, is if you want to print the letter N, well, be my guest. You print the letter N all day. Now, obviously, we're going to need an update. We know this one, Ben. Honestly, get with the program. I'll show myself out. So what we're doing is we're just making a simple loop which just prints the value. No, we're not even printing the value. I've just made a total mistake there. We're not doing that yet. We're just printing the letter N. Ben put speech marks around our print value here, and that tells Fuse that this is just something that we want to appear on screen. It actually says this is a string. It's a type of data. It hasn't got a value. We can't do that times 10. It doesn't really make any sense. But it's just a series of characters. I mean, in this case, it's just one character. But Ben could add a bunch of spaces or some numbers or anything to that string. And now that string contains all of these different things. And we're just printing that. Now, we can put anything in speech marks and it will print. Fuse doesn't mind if it makes sense or not, or if it's grammatically correct. You put it in speech marks, it will appear. But that is not the same thing as our variable N. When we do not have speech marks, Fuse is looking at what's in the brackets and it says N. Well, that's not in speech marks. You must already sort of have told me what this means. Let's look elsewhere in the program, and it will go up to line 1, see that N is equal to 2, and then it can go into that box and print the value that is stored there. And here's all those 2s. Look at those 2s. Off they go. It's never going to get old pretending that they go off screen. I mean, not pretending. They obviously do. So we've got 2s everywhere now. Now, Ben can easily just change the value stored in N. We just simply change the initial declaration. And when I say declaration...
That didn't really help, did it? Let's try 23.
Yeah, there we go.
Okay, there we go.
2, 3, 2, 3, 2, 3, 2, 3. That's fantastic, that example. This will show you, it's going to be so different. It's going to blow your mind. Watch, 22 this time. So yeah, easy enough. Now, I use that word declaration because we have to declare the value of a variable, or we define. And you might hear these 2 different words used all over the place. Defining a variable, declaring a variable, initializing a variable. That is on line 1. We are just saying, this is this. Now, this is not really what we use variables for here. We tend to use variables so that we can manipulate their values during the program. And we can do a ton of awesome stuff with that. But just to show you operationally, like mechanically, what is happening when we want to manipulate the contents of a variable, let's just do something really, really simple. Let's just increase it by 1 as the loop goes on.
Okay, so Dave, how do we increase it by 1?
I mean, this is actually a statement which, if you're completely new to programming, this might look a bit weird, but only just for a minute or so. What we want to do is we want to reassign the value to n. So if you put n equals, right, now currently n is 23. We've got that at the very top of the program, so we know n is 23. But on line 4 now we're saying, okay, well, and now I want n to equal something else. And if we want to increase it by 1, we do not want to say n equals +1 or n equals 24, because this is just going to increase it by 1 once. If we want our loop to keep increasing it by 1, we need to redefine n to be whatever it is plus 1. And that looks like this. N equals n plus 1. So we say take the value of n and let's make it whatever it currently is plus 1. And this will keep happening. And as you can see, we've got a whole mess of numbers going all over the screen there.
So something we can actually do is inside of the print.
I was just going to say this actually, yeah.
So before we've mentioned how many parameters functions like print and update can accept. Update does not take any.
That's right.
Print can take as many as you want.
As many as you want. You can just put one thing, or you can put multiple things separated by commas, and Fuse will just print them all one after another. It's really, really helpful if you want to have a sentence with parts inside it that might change. In fact, you're going to see that in a minute. So if Ben puts n and then a space, and this time we do need speech marks because we're saying I want this space to appear. Otherwise, it just really won't exist otherwise. Now what we're going to see is the value of n followed by a space. And now it doesn't look so confusing to the eyes. You can actually see 24, 25, 26, 27, 28, etc., etc. And it's just going to go off screen there up into the 60s. Now, there is another way of writing what we've got on line 4. And this one is something that you might have seen if you've read any of the Fuse tutorial content or you've had a good look at the keyboard. You may see some weird looking symbols that you've not seen before. If you just take a look here, I'm guessing it's there.
Yeah, it's up there somewhere.
Yeah, it's up there, so it's like here. You will see symbols that are called plus equals, minus equals, times equals, and divide equals. And it just looks like that symbol followed by the equal sign. Now, because it can be quite time consuming to have to write out variable name equals, variable name plus value.
Especially when the name of your variable
is not just n.
About 20 characters long.
You might have lots of different variables, or even you might have a very, very complex data structure which you need to write down the whole value of, or the whole name of, sorry, and it ends up really taking up a lot of time. So some time ago, I'm not sure when it actually came about, or what language it first appeared in, but the convention is now that we use these combined symbols to write this sort of a statement. And this statement becomes n plus equals 1, which just means n is now equal to whatever n is plus 1. And exactly the same applies to minus, times, and divide. We can change that plus for a minus, and instead of counting up from 23, we're counting down from 23, and it'll go into the minus numbers. Almost exactly mirrored, actually, weirdly enough.
Yeah, it's one off.
Starts at 21 and then we end at minus 21. Sorry, 22 and it ends at minus 21. It's really strange. Okay, so this is hopefully giving you a bit more meaning to some of the symbols that you might be seeing all over the programs that are included in Fuse. If you take a look at the Fuse demo programs, you might be a little bit intimidated at first by some of them are very, very long and might contain some complex looking math statements with some really weird looking words. But rest assured, it's actually a lot more simple than you think. They're just variable names, and they have been decided on by the person who wrote the program. So you can make your variable names as simple or as complicated as you like, and using them, you can really do some awesome things. Now, we've got a basic counter here, and that's it. So hopefully you understand what's happening. We have initially, just to cover it again, stored a value in a place. We've labeled that place as n. Then we are increasing the value of it. We're redefining it, increasing the value. Then we're printing the value, followed by a space. We're updating the screen, doing it again and again and again, and this is just going to keep repeating. Okay, so how could we take this and apply this idea to an actual program? Well, we've got a treat for you. Now, you might not know, depending on where in the world you're viewing this from, but we British people tend to like cups of tea. You probably do know this, as it's one of the most sort of famous cultural tropes. On that vein of thought, we did a little program earlier, sort of, Art Attack style here, called Biscuits. Because we like biscuits. I mean, who doesn't like biscuits, really? Biscuits are good.
Everyone loves biscuits.
Everyone loves a good biscuit. And as you can see at the top of our program, we have declared a variable called Biscuits, and we've made it 10. Because you've got a pack of 10 biscuits, you're loving life. You've got 10 biscuits, you've got a cup of tea. Doesn't get better than that. Now, on line 3, we've got a very thematically appropriate ink colour as bisque. And we've also declared another variable just underneath that. And this variable is called cuppa, which, if you don't know, means a cup of tea, a cuppa for short. And we have assigned to that variable a colour, and that colour is sand. It's not my sort of favourite cup of tea colour. I tend to like it a bit darker than the sand colour we've got, but it will do for the purposes of this demonstration. And just underneath that, we are adjusting the text size to make it a little bit bigger so we can see it clearer. And now we actually begin our main loop. So the first thing that we do is we clear the screen. And here's an example of using the clear function, which does not need anything inside the brackets. But we can put a colour inside the brackets, and it will clear the screen with that colour. Now, we could have just written clear and then sand in the brackets, but where's the fun in that? It has to be tea-themed. So we did a cuppa variable, and we're clearing the screen with our cuppa colour, which is sand. You confused yet? Believe me, so am I. Okay, next line. We are printing. Now, here's a great example of, one of those print statements that's got multiple strings separated by commas, and we're sort of changing things as we go. We've got this print statement that the idea here is to print how many biscuits we have.
Yeah.
So it says, I have, and then it says the word biscuits, but we do not have speech marks around that word biscuits, and you can see because it's not highlighted in that string colour blue. That is just the name of our variable. So just like n, when Fuse read print n, Fuse will read biscuits. It's going to go up to wherever biscuits is, find that value, and then print that. So this print statement will say, I have 10, and then it's just going to put the word biscuits. Now you'll notice that we've got spaces on either side of our biscuits variable. We've got a space just after I have, and a space just before biscuits. And this will just allow Fuse to print it all nice and spaced out. If we didn't have those spaces, it's going to say, I have 10 biscuits. I can't say that very well.
I have 10 biscuits.
I have 10 biscuits.
Yeah.
So it just won't look very neat. And you want to have spaces between things so it all reads properly. If you haven't seen that little \n before, we can use that very, very handy little character to begin a new line in a print statement. So once Fuse has read this, it actually will not print that \n. Instead, it knows that this means something, and it will just put the cursor on the next line to print something else. So we're going to print, I have 10 biscuits. Then we update the screen because we want this to appear for a little bit of time, half a second. So we've got an update, we send that to the screen, we sleep for half a second, then we print.
This just means stop everything.
Ooh.
And
we didn't talk about this yet.
No, we used loops.
Yeah. We used a loop, but we haven't used sleep. So do continue.
Yeah, so it just stops the program, sleeps, or in Fuse Basic, Fuse Basic, we use a similar kind of thing, which is wait.
Yeah, if you are watching our videos and you have been to a Fuse workshop before, or even one of our holiday club workshops, you will know this command as wait. It's exactly the same, isn't it? Yeah. It's just sleep, and you put a number in there, and it will just do nothing for that amount of time. So we're sleeping for half a second because we wanted to have a slight delay before we then said the next thing. And this next bit gets me a bit emotional then. We've all experienced this sort of loss when you are dunking a biscuit in a lovely cup of tea and it falls in I mean, I'm actually drawing upon some real emotion here to access that, because it is not. There's nothing worse. You're dunking a lovely biscuit in a cup of tea, and it's just suddenly gone because you went for that one extra dunk, didn't you, Ben? You went for one too many dunks. You shouldn't have done it.
Or too long.
Or you just held it in there for too long. Yeah. Either one, you know.
Put down in the comments which type of person are you? Multiple dunks or long dunks?
I like that idea. Also, put in the comments what your favourite biscuit is to dunk in your tea. And if you don't dunk biscuits in tea, then we just don't want to hear from you. No, we absolutely do. Please tell us that, or anything that you want.
We would love to hear that you started dunking your biscuits after watching this video.
I mean, you have to give it a go. It really is amazing. So we're printing if I lose one in a tragic dunking accident, then. So we have 10 biscuits. If I lose one by dunking it in my tea for too long, then what happens? Well, if you look at line 15, we've got our key player here. We are subtracting 1 from the value of our biscuits variable. And this is just a loop that will keep going round. So hopefully we are going to very, very sillily keep dunking biscuits in our tea for too long, not learning from our mistakes, and eventually we're going to have a really disgusting cup of tea full of biscuits. Let's see. There's our lovely background colour. I have 10 biscuits, 9 biscuits, 8 biscuits, and we're dunking each time. And so you can actually see now that this is just counting down in a context which sort of looks more like a real program.
Yeah.
Now, obviously, this isn't a game. This is not enough to be called a game. But you can imagine where you might apply this sort of mechanic in a game. If you are displaying health, if you are displaying a number of items in an inventory, for example. And I'm actually noticing here that we have really gone off the rails.
For some reason you want minus biscuits.
Yes, I was just going to mention. We're now in the minus biscuits range because, you know what? Computers do not understand reality and they do not mind displaying minus biscuit amounts. We had 0, but you can keep going. And in fact, we use negative numbers all the time. They're so useful. If we didn't have them, then we really would be in trouble.
And in fact, I'm sure Dave and I would love to be able to eat biscuits when we have 0 biscuits.
We can still eat them somehow. The universe, we have to just sort of owe the universe biscuits. It's like the whole biscuit tax thing. I mean, it would be very, very dangerous to introduce a biscuit tax, although probably very profitable as well.
Yeah.
Because, I certainly wouldn't stop eating biscuits. Now, what if we didn't want to have this program go into the negative numbers? And I want to just quickly use this chance to introduce a little modification to our loop line. What we can do is we can add a keyword here called while. And this allows us to perform a check in the beginnings of our loop. We can say while our variable name biscuits is greater than 0 loop. And this will keep happening as long as we have more than 0 biscuits. Now we'll have a bit of a problem because when we get to 0, we're no longer going to be looping and we will actually just come straight back into the end of the program. So we might have to add something else to this if we really wanted it to give us what we wanted. But actually, I've got a better idea of how we could change this, Ben. Let's go the other way instead. Instead of eating biscuits, why don't we generate biscuits? That's way better. Why have we been eating biscuits? We could just be creating biscuits out of nowhere, 10 at a time, by buying packs of biscuits. That sounds like an idea that we definitely did not have before. So we do not have this piece of prepared text at the bottom of the program here. So if we take that, and that's right, copy that. We can put that instead of our if I lose one in a tragic dunking accident then, because it doesn't really make sense to lose a biscuit, then gain 10 biscuits. But we are going to have to change a couple of things here.
Because if we run it at the moment,
we're
buying 10 biscuits and we're losing this. That doesn't sound like a very fair deal.
That does not sound like a very good sort of situation. So we need to change our line 15. We're not reducing our biscuit value anymore. We are increasing the value of biscuits and we're buying 10 at a time. So in fact, we need to say plus equals 10. And we should start with 10. Buy a 10 pack from the shop. 20. Okay, this is more my sort of game. 40 biscuits, 50 biscuits. In fact, Ben, you know what? You just leave that running for the rest of the day. We'll see how many biscuits we can get.
Sounds like a great plan.
Sounds like a great plan. We're going to need, we'll need a lot of tea to get through this many biscuits. But you know what? it can be done. So and
Why
we're
don't you
definitely-
create a program for yourself? Try and generate some tea.
Okay, why not?
How much tea can you create?
You should definitely try out your own counter programs and just get used to manipulating what is inside a variable and using those variables elsewhere. Feel free to just go as wild as you want with this, okay? Add variables together, multiply them by each other. The more you do of creating variables, changing what's in them, the more comfortable you're going to feel in these later projects, because after the next video, in which we look at if-then statements, which are our third super important key concept for programming, after that, we are going to start delving into some more advanced concepts, some more advanced data structures, or even actually starting to make our own little games. Because with that out of the way, we really can start making games.
Yeah.
So do stay
Absolutely.
tuned. Hope you've had a good time with us. Enjoy your tea. Hope it hasn't gone cold. And I've been Dave.
I've been Ben.
And we'll see you next time.